Today, we're going to use a simple game to unpack one of the biggest ideas in philosophy and politics, the social contract.
I mean, it really all boils down to this one big question. Why would we ever give up some of our freedom for a bunch of rules? It kind of seems backward, but trust me, by the end of this, you'll see the powerful, rational logic behind it all.
So, here's our game plan. We'll start with a simple dilemma, dig into the rational choices people make, see how adding rules totally changes the game, figure out the costs, and finally, reveal the social contract itself.
All right, let's jump right in. We're starting in what philosophers like to call the state of nature, a world with absolutely no laws, no police, nothing, just you and your neighbor.
The setup is super simple. You've each got a plot of land, you both got to eat, but without any kind of established order. You have to decide, how are you going to make that happen? You've got two basic choices. You can forbear, which just means you stick to your own business, work your own land. Or you can steal and spend your energy taking your neighbor's crops instead of growing your own. And remember, your neighbor has the exact same two choices.
Okay, let's put some numbers on these outcomes to make it real. The absolute jackpot for you is to steal while your neighbor works. That gets you a sweet payoff of 12. The next best thing is peaceful cooperation. You both work your farms, you both get a solid 7. Way down the list, if you both try to steal, you just end up fighting over scraps and get a measly 2. And the absolute worst, you do all the work and your neighbor just waltzes over and takes it all. That leaves you with -2.
And this is where the payoff matrix comes in. It's like our game board, laying out all the possibilities. In each square, the first number is your score, and the second is your neighbor's. So for example, if you steal while they forbear, you get that awesome 12, and they get that terrible -2. So looking at this whole board, what's the smartest move for you to make?
So let's break this down from a purely rational point of view. What's the best choice for you, no matter what your neighbor decides to do?
To figure that out, we need this key idea from game theory, the dominant strategy. Now, this isn't just about your best possible outcome. It's the one single move that gives you a better result, period, regardless of what the other person does.
Okay, let's walk through this. Let's put ourselves in your shoes. First scenario, assume your neighbor is going to play nice and forbear. Well, you could also forbear and get a 7, or you could steal and get a 12. 12 is way better, so you should steal. Okay, scenario 2. What if your neighbor decides to steal? Well, you could forbear and get a -2, or you could steal back and get a 2. Again, 2 is definitely better than -2, so once again, you should steal.
Are you seeing the pattern here? No matter what your neighbor does, your best move is always to steal. That's your dominant strategy. And since this whole game is symmetrical, your neighbor is doing the exact same math and coming to the exact same conclusion. Their dominant strategy is also to steal.
So, where does that leave us? We land right here. Both of us, just by following our own rational self-interest, end up choosing to steal. This is the Nash equilibrium of the game. We both get a payoff of 2. Yeah, it's a stable outcome, but look at it, it's awful. We could have both gotten a 7 if we just cooperated. This right here is the classic problem of the state of nature.
So how do we escape this trap? How do we get out of this mess? Well, we have to change the game. Let's bring in an enforcer, a sheriff, who can actually punish bad behavior.
We'll call this punishment P, and it's basically a cost that gets subtracted from the payoff of anyone who chooses to steal. The whole idea is to make stealing a much less attractive option.
Here's our new and improved matrix. You can see how P gets taken away from any outcome where a player chose to steal. So the million-dollar question now is, how big does P have to be to completely change our behavior and get us both to cooperate?
To get to that peaceful, cooperative society we're hoping for, we actually need to satisfy 2 conditions. First, we have to make mutual cooperation, that forbear-forbear outcome, a stable, rational choice. And second, we have to completely break the old, nasty equilibrium of steal-steal and make it an irrational move.
Let's hit that first condition. If your neighbor is forbearing, you need to actually prefer to forbear too. That means your payoff of 7 has to be at least as good as the payoff for stealing, which is now 12 minus P. A little bit of simple algebra tells us that for this to hold true, P has to be at least 5.
Now for the second condition, and this one's a little subtle but super important. We have to break that old steal-steal habit. So let's say your neighbor is going to steal. You need a real reason to choose forbear instead. Your payoff for forbearing is -2. Your payoff for stealing is 2 minus P.
Now, if the punishment P is exactly 4, your payoff for stealing is 2 minus 4, which is negative 2. See the problem? That's the exact same payoff as forbearing. You're indifferent. You might as well flip a coin. Stealing is still technically one of your best responses, so there's no clear incentive to change. But to guarantee you'll switch, there can't be any doubt. Forbearing has to be strictly better. And that only happens if P is greater than 4.
So, we've got our two conditions. P has to be greater than or equal to 5, and P has to be strictly greater than 4. To satisfy both of those, the absolute minimum value for our punishment P has to be 5. With that, cooperation finally becomes the new rational choice. But, this system of enforcement isn't free. That sheriff needs to be paid. And this brings us to our next variable, the cost of actually maintaining this new, peaceful society.
We're going to call this cost a tax, or T, and this tax gets subtracted from every single outcome for both of us. It's just the price we have to pay to have the sheriff around. So now, with both the punishment P and the tax T in the mix, we can finally ask the ultimate question.
Is this whole system, this civil society, with all its rules and costs, is it actually better than the chaotic state of nature we started with? Let's find out.
Okay, the choice is now between two entire worlds. In the old state of nature, the logical outcome was everyone stealing, which gave us a payoff of 2. In our new civil society, the logical outcome is everyone cooperating, which gives us a payoff of 7 minus the tax, T.
For us to voluntarily agree to join this new system, the payoff we get has to be at least as good as what we had before. So our new payoff, 7 minus T, must be greater than or equal to our old payoff of 2. The math is super simple. The tax, T, has to be 5 or less, and this is the whole point. We are rationally willing to pay a price, a tax up to 5, to fund this system of rules. Why? Because even at the maximum cost, our final payoff of 2 is still no worse than the guaranteed misery we had back in the state of nature. And any tax less than 5 means we are definitively better off. And that, right there, is this social contract in a nutshell. It's a rational bargain. We give up the freedom to steal from our neighbor, and we agree to pay for the system that enforces the rules, because the peaceful, predictable society we get in return is so much better than the logical but brutal alternative.
It's pretty amazing how this simple model of two farmers reveals such a deep truth about our world. So the next time you stop at a red light or pay your taxes, you're actually participating in this very game. And it leaves us with one last thing to think about. What other invisible rules and agreements are we all upholding every single day just to keep the game from falling apart?